So let's talk about one of the biggest challenges in AI right now. You want your AI to be incredibly smart, right? But you also need it to be right. You need it to be factual, especially when it's dealing with your own private up-to-the-minute data. Well, there's a game-changing technology solving this very problem. It's called Retrieval Augmented Generation, or RAG for short, and in this explainer, we're going to break down exactly how it gives AI a reliable brain.
I'm sure you've seen this happen. You ask a chatbot a really specific question, maybe about a new company policy or a product that just launched, and it spits out an answer that sounds super confident, but is just completely wrong. So why do these incredibly powerful tools sometimes just make stuff up?
Okay, this slide really gets to the heart of it. On the one hand, you've got your standard large language model. You can think of it like a flawed genius. It's brilliant and creative, but if it doesn't know something for sure, it might just fill in the gaps, hallucinate an answer. But a RAG system? That's totally different. It's like giving that same genius a library full of fact-checked, up-to-date books and telling it, you can't say anything unless you can point to the source. The result? You get a grounded, factual answer you can actually trust.
To really get why RAG is such a big deal, we first have to understand the problem it's solving. Let's take a closer look at exactly why these standard AI models can sometimes get things so wrong.
A plain LLM has a few major weaknesses. First off, its knowledge is static. It's basically frozen in time, with a knowledge cutoff date. It doesn't know anything that happened after it was trained. Second, it has absolutely no access to your private, internal documents. And because of those two things, it's really prone to hallucinating when you ask it something outside its training data. And finally, it has no way to get real-time updates from the world. It's stuck in the past.
So how do we fix all that? How do we give an AI access to current, private information without it making things up? Well, this is where RAG comes in. It's a really elegant solution to all four of those problems we just talked about.
Now, the name, Retrieval Augmented Generation, sounds a little intimidating, I know. But the idea behind it is beautifully simple. Let's just break it down. Retrieval is just a fancy word for searching and finding the right piece of information from a knowledge base. And generation is what these large language models already do incredibly well, taking information and creating a natural, human-like response. That's it.
So it all boils down to this really simple formula. And if you remember one thing from this explainer, make it this. RAG is about combining a powerful search function with the right context to generate a trustworthy answer. Search, context, generation. That is the secret sauce.
Okay, so let's get into the nitty-gritty. How does the system actually find the right information? Because this isn't like the keyword search you use on Google. The real magic here is all about understanding the meaning behind what you're asking.
It all starts with this amazing concept called embeddings. Really, you can just think of an embedding as a way to translate words, sentences, even whole documents into a set of numbers, a sort of coordinate, also known as a vector. Imagine a giant 3D map of ideas, where concepts with similar meanings are plotted really close to each other. So on this map, the phrase company vacation policy would be located right next to how much paid time off do I get, even though they don't share many of the same words. This is how the AI understands your intent, not just your keywords.
And where do we keep this incredible map of meaning? Well, that's where a special kind of database comes in, called a vector database. It's like having a hyper-intelligent librarian. You don't have to give this librarian the exact title of the book you're looking for. You can just describe the idea of what you need, and the librarian instantly understands and pulls the most relevant books off the shelf. That's exactly what a vector database does for your data.
So let's put it all together and walk through the pipeline. First, your question gets turned into one of those numerical embeddings. Second, the system searches the vector database to find the information chunks with the closest meaning. Third, it grabs or retrieves those top results. Now, fourth, and this is the most important part, it stuffs that retrieved information right into the prompt it sends to the LLM, giving it all the context it needs. And finally, the LLM uses that context to generate an answer that is now grounded in the actual facts you provided.
And hey, this isn't just some abstract theory. This is happening right now. Developers are building these systems using a whole stack of specialized tools. They'll use an embedding model to create the vectors, a vector database like Pinecone or Weaviate to store and search them, and then they'll pipe the results into a powerful LLM from a place like OpenAI or Anthropic to generate the final answer.
Now, this all sounds really effective, but it does bring up a pretty important question. Is this really the best way to do this? What about the other options for getting new knowledge into an AI?
Yeah, you might be thinking, look,
Why go through all this trouble with vector databases and stuff? Can't we just retrain the entire AI model on our new documents? It's a great question. That process is called fine-tuning, and while it's useful for some things, when it comes to keeping knowledge fresh and up-to-date, RAG has some really serious advantages.
When you put them side by side, the difference is pretty stark. With RAG, there's no retraining of the model itself. That means updates are super fast and easy. You just add a new document to your vector database. With fine-tuning, on the other hand, you have to retrain the whole model, which is incredibly expensive, super slow, and makes it really hard to update frequently. The bottom line? For pretty much any use case that needs current information, RAG is just way more agile and a heck of a lot cheaper.
All right, so we've covered the how and the why. Now let's get to the fun part, the where. Where is this technology actually being used to make a real impact today?
The applications here are just huge, and they're incredibly practical. I mean, think about building an internal bot for your company that can instantly answer employee questions about HR policies or technical procedures. Or what about a customer support AI that gives perfect answers based on your latest product guides? You can use it to let people ask plain English questions about super dense legal or financial documents. Basically, anywhere you need an AI to have deep, accurate knowledge about a specific and changing set of information, RAG is the perfect tool for the job.
So let's bring it all home. The big takeaway is this. The path to smarter, more reliable AI isn't just about building bigger and bigger models. It's about cleverly connecting those models to the right information at the right time. And that's the power of that simple formula. Search plus context plus generation. So, I'll leave you with this thought. That barrier that used to exist between these powerful AI models and your own specific, private, up-to-date data, it's pretty much gone now. So the question is no longer if an AI can understand your knowledge base. The question is, what knowledge are you going to give it? What incredible problems are you going to solve when your AI finally knows what you know?